All right, so this is number 29 out of section 4.2, page 274 in the book. Similar to number 23, although I'm going to do this one, I don't want to necessarily say shortcut, but more or less we're going to take a little bit of a shortcut here for this one. So in this problem, we're given an angle. Now, one negative to this angle that they gave us, haha, get it? It's a pun. Is that it is a negative angle. Now, negative angles are bad for a few reasons. The main reason that it's going to be an issue right now, I mean, one of the reasons would be that they might be a little confusing. But if I'm going to use my the kind of known values that I have from the unit circle, all of them are positive. So I'm going to need to go ahead and convert that into a positive angle. Now, the principle that I'm going to use to do that is the simple fact that if I have some angle here, it doesn't matter which way the angle is going, but I have some angle, negative theta, okay? Now, with that angle, the issue here is that it's negative. So what I can do is if I travel in a complete circle, that if you notice my location is in the exact same spot. Well, this travel right here would be defined as plus 360 degrees, or since we're dealing in radians, it would be plus 2 pi. So I can always add 2 pi, and in fact I can also always subtract 2 pi to make sure that the angle I am using, okay, is between 0 and 2 pi. Okay? So basically, and we learned about this in the prior section, what we're finding is a coterminal angle. Okay? Because coterminal angles will have the same sine, cosine, and tangent, okay, as each other. So doing that, or kind of going off that, what I'm going to do is I'm just going to take my angle here, negative 3 pi over 2, and I'm going to say that if t is equal to negative 3 pi over 2, well, it's also equal to 2 pi. And we also know that 2 pi ends up at the same spot on our circle as 0. So in reality, it's like we're adding 0 to this. Okay, so I'm going to rewrite that. I need a common denominator here, and I get negative 3 pi over 2 plus 4 pi over 2. Okay, we add those up, and we're going to find that that's the same as negative, or I'm sorry, positive pi over 2. Okay? So if I find the sine, cosine, and tangent for pi over 2, I'm going to be in good shape. Now, from the prior lesson, and if you haven't looked at this, definitely, or looked at it, go ahead and take a look at number 23, because I'm not going to repeat that information. So if I want to find the sine of pi over 2, which again we said is the same as the sine of negative 3 pi over 2, well, that's going to be equal to y. And cosine of pi over 2, well, that's going to be equal to my x value at this angle on the unit circle. And tangent is just equal to y over x, and those have to do with our trig properties, so katoa. Okay. Oops, I wrote that one wrong. Sorry, sine of pi over 2 is equal to y over x. There we go. Now, based off this, what we're going to go ahead and do is we're going to just take a look at our unit circle here. And I'm going to look at the unit circle, and I see that, well, if I go travel to pi over 2 right here, then what I end up having is I have a coordinate for pi over 2, and I have my x value and my y value. So my x value is 0, and my y value is 1. So I see here that sine of pi over 2 is just going to be equal to the y value at that point. Therefore, it must be equal to 1. Cosine of pi over 2 is equal to the x value at that point. So it must be equal to 0. And then I go to the last one, and I see, well, tangent of pi over 2 is equal to y over x. So I take y, which is equal to 1, and put it over x, which is equal to 0. And we find that, well, Tangent is undefined at pi over 2. And we're done. So if you did take a look at number 23, you can see how much faster it is once we're familiar with our given, or kind of our common, radian and angle values.